Hi, and welcome to this Scottish Summit session where I'm going to tell you all about how I decided to develop my own product, start a company, and build this startup on Microsoft Azure. This is not a sales session. We're actually going to get quite technical. So thank you for joining me here virtually, and remember to ask questions in the chat. So before we jump into the session, I just want to take this quick opportunity to thank all the sponsors of this year's Scottish Summit. Without you, this conference would not have been possible. So who is this guy? I'm David O'Brien, and just to address the elephant in the room, I'm half Scottish, half German. So you've probably already wondered what this funny accent is. But one cool fact about me, and you probably wouldn't have guessed that, is that I'm from the future, by 11 hours actually at the moment, because I live in the beautiful Australian regional town of Geelong. Well, apart from that, I've been a Microsoft Azure MVP for quite a few years now. And last year, I founded a startup called ARGOS Cloud Security. ARGOS here refers to the all-seeing figure from the Greek mythology, because that's what it does. ARGOS sees and watches over your cloud security in all your cloud environments. So if you want to get in touch with me, then Twitter is usually the best way to go. And you can find me there at David_O'Brien. Enough prologue, let's get into it. The session subtitle is How to Make Scaling a Sales Issue and Not Tech. And this is exactly what we're going to talk about. We set out to build something great, and we didn't want to see any performance bottlenecks or slow demos for our customers. We needed them to trust that we knew how to build a robust and secure platform. The only problems we wanted to experience were how to grow our customer base. So where did we start? One day, while working on a cloud consulting gig, about 2 years ago now, a security incident happened. After that incident, I talked to a few people in my close network about this incident and how I thought that there has to be a way to make sure that an incident like this isn't going to happen again. And that's when I decided, in the midst of a pandemic, to start a product company. Well, the fundamental premise of our product idea was that, and still is, that even after years and years of public cloud being a thing, we still seem to be getting the basics wrong. This isn't me saying that we don't know what we're doing or pointing fingers at people, but really more that cloud isn't easy. And that following the deploy X, Y, or Z in 3 simple steps, tutorials that we might see on the internet, they usually end in tears. Cloud platforms change as we're working on them, right? And that might have been okay to, and something that might have been okay to do yesterday could potentially be seen as a security risk today. We hear about databases being put onto the internet, firewalls being left open or being opened up, websites exploited, and many other things pretty much on a daily basis. So this was an opportunity to start developing the idea and get rich quickly, right? At least that's what I learned from watching the TV show Silicon Valley. And if you don't know that show, you should really, really go and watch it. Teaches you a lot about building startups. Reality, however, is not a TV show. Even though Silicon Valley comes painfully close sometimes, we're still self-funded. So we need to make sure we don't go broke while trying to build this application. And we truly believe in what we're doing, but we often face the issue that organizations rather buy from large vendors than buy an early product version from a startup. And that means that money is even scarcer. As a startup, you are rarely judged differently, though, especially by larger organizations. So there are a lot of expectations we need to, and frankly, we also want to meet. In the early days, customers might let us get away with a few things, but overall, even for a free tier or free offering, people still expect premium outcome. So of course, we promise this to our early adopters and customers. We want them to be delighted when using our product. But how do we make all of this a reality? How do we make all of this not a technical problem, but make it easy for the developers and make sure the only stress is more on the sales team and salespeople from being almost overrun by customer requests? Well, first of all, we had to understand a few things about ourselves and make some important decisions. Who is working on the team and what skills does the team have? In this case, the development team mostly, because there's no point in selecting a certain programming language if nobody on the current team knows how to write in that language, for example. We needed to make an educated guess about our likely traction for the next 6 or so months, maybe even 12 months. But then things get a bit foggy, right? Because we didn't want to build an app that can scale to thousands of users a day on day one, if realistically we were trying to get feedback on our early MVP version. Similarly, we also didn't want to build something that as soon as somebody actually started using the app, we would have to go and refactor or rebuild. And we also live in the real world, so we had to understand how much runway we actually had available to us and how much money we were able to spend on our infrastructure. And all of that really turned into some non-negotiables for us that had to be true for the foreseeable future. This is what we came up with. Our golden rules, ideally not to be broken. Based on our available skills and relationships, we decided to go all in on Microsoft Azure. And what does all in mean in this case? It means we didn't think about scenarios like, what if we needed to move to a different cloud provider in a year or two? We believe that for a startup, and actually not just for startups, actually, this kind of thinking distracts from delivering value. We'd be busier writing code that works everywhere, sort of, instead of writing code that works really, really well in one spot and delivers value to our customers. This is also why we decided to use as many serverless services, serverless in quotes, as possible. Because our business is not to sell virtual machines, figure out how to patch them, deploy Active Directories, and join stuff to them. We make money by delivering value to our customers. And frankly, they couldn't care less about the infrastructure we're running on. They just want the app, right? Just like on our phones, we don't care what infrastructure somebody is running the app on. We just want the actual app. Or people also say similar things about banks. People don't want banks, they want banking. So going serverless to us meant we were able to do exactly that and write great code, deliver and test new features quickly in order to get customer feedback quickly. All of this also came with a strict focus on security. We are a security product, and in our opinion, that also means if we don't follow certain security practices, then we have failed. We mustn't take any shortcuts, or especially when it comes to security. Azure offers many services that have free tiers or plans that are free to a certain point. And I'm going to mention that a bit later again. And this was and still is very helpful to us. Similarly, if we needed to integrate with a third-party solution, and there were more than one that were good enough really for our purpose, then the one with the beta tier or startup tier was selected. And this goes really hand in hand with buy over build. Or you might have heard that before. If there's a solution that does what we need to do, then we would buy the third-party solution, examples of which are sending emails, authentication, or payment services, all of which are really important to us, and all of which we found great SaaS solutions for, that we were able to buy rather than build ourselves. Last but not least, everything had to be automated. CI/CD all the way. No, I'm just going to quickly click this one thing. That wasn't supposed to be a thing, and it's not. Well, and this is our first architecture diagram we came up with. Super fancy diagram, I know. Well, I'm going to go into the details next, but at a high level, you can see our core application in the center. It's a .NET Core Azure Function app, actually, and it runs on Linux. And that does all the heavy lifting of our app. Our front end at the top, at 12 o'clock, is an Angular app hosted behind an Azure CDN on Azure Storage. And the backend at the bottom is an Azure Cosmos DB. As you can see, no servers anywhere, no domains to manage, no printers, nothing. But you can also see some services here that we integrate with, like Auth0 at 1 o'clock for authentication and single sign-on of customers. And Auth0, by the way, also gives us multi-factor authentication out of the box, and for bring your own identity, like Azure AD. If you've got MFA on there, it just works with the application as well. So that's amazing. Stripe on the 3 o'clock is used for payments, which is amazing because that means we don't have to worry about storing credit cards and being PCI compliant, for example. SendGrid at 7 o'clock is another example for third party. And I could ask to put your virtual hands up if you think we should spend time installing Exchange servers instead to send emails to our customers. Because we didn't. So let's dive a bit deeper into our infrastructure and the services we chose. Starting with the front end, we have the Azure Storage account that hosts our website with the static website feature. Our Angular app is a perfect candidate, really, for this feature, because all we have to do is build the front end and build the app, the front end in our pipeline, copy it to storage in our storage account container, and we're done. We do have Azure CDN in front of it to accelerate global delivery of static content, but overall, no VM to deploy, no need for IIS or similar web servers, no patching, don't worry about high availability, because we can easily make the storage available beyond the Azure region we've deployed it into. And all of this really for the amazing cost of $24. And that's Australian dollars, by the way. So for you, probably almost nothing. The way we deploy our infrastructure, we mentioned everything needs to be automated, is by using the open source, completely free infrastructure as code service called Pulumi, P-U-L-U-M-I. The snippet here that represents our website can be seen here. We chose TypeScript for our infra code as that most closely aligns to our skill set internally. Our website is written in Angular, as I mentioned, so it's also TypeScript. Here and everywhere else, you will also see traces of our security approach. Here we enforce HTTPS, and we enforce it everywhere end to end. So on to the most exciting bit, really, the actual application. The app is hosted on Azure Functions, which fits our serverless requirement, and it was hosted on a Linux dynamic consumption plan. I'm going to get into the past tense later on. So yes, we run our .NET application on Linux because, well, why not? Who cares about what OS something runs on? The app surely doesn't, and it means that for our developers, they can run it and build it and develop on it on a Mac, on a Windows, on a Linux machine. Doesn't really matter. The consumption plan was really nice because it automatically scaled as required. However, each sandbox the functions run in only has about 1 GB of memory available. This will become important later on. What's also great about the consumption plan is that the first 1 million executions are free. So that was really good to know for us, because initially we didn't have that much, but over time we knew we were going to execute quite a number of functions every month. So in the screenshot, we show the infra code for the app service plan that hosts the function app and the config for the consumption plan. We already had the commented out code in here to deploy the plan as a premium plan. So yeah, it would be this easy for us to change from the consumption to a premium plan. So we already knew, we already prepared for the point in time where we had to redeploy. And this is what we really like about using these services, the flexibility they give us when demand goes up. And the function app itself has a few more lines of code in it, but nothing really compared to what people might be familiar with, these really long lists of instructions on how to deploy a virtual machine, configure a virtual machine, click here, click there, type this in. But yeah, here again, you can see the HTTPS only setting we enforce everywhere. Also, we don't have any hard-coded or even known to us credentials in our app where we need to communicate with other services like Key Vault, for example. As you can see here under identity, we use the Azure Function Apps Managed Identity. Super easy, really simple to use. The app itself currently has around 70 functions defined, and probably now closer to almost 80, but somewhere between 70 and 80. And quite a few of them are part of the actual website APIs. But the core functionality uses storage queues quite heavily. They make the actual scaling of functions so much easier compared to virtual machines, for example. And they are really easy to integrate into Azure Functions using the functions input and output bindings feature. In the screenshot here, you can see how easy it is that in only 2 lines of code, we can configure and tell this function to output everything onto the scan request queue. Yeah, I can only say our developers and I also really love how functions, how they make it so easy for us to do this. Knowing that this saves us the hassle of writing all of this code ourselves, obviously. If you're not familiar with queues and the overall concept of it, the way it works is fairly simple. Instead of having that one function that does everything, we have this timer triggered function that executes on a timer basis. And all it really does is it checks the database for what needs to be done. And then every instruction basically gets put onto the queue as a message. At the moment, that's around roughly 800 messages every minute. And this number will only grow as we grow. So every time a message ends up on the queue, our queue triggered functions in the backend fire, and if one function instance isn't enough, Azure knows how to scale out to many more instances as required. They pick the messages up, do what needs to be done, and then they go away again. We only pay for the actual execution runtime, the execution time, which is usually at the moment somewhere around 1 to 2 seconds. And all of this is fully managed by the platform. As I said, functions in the consumption plan scale automatically. Nothing we need to worry about. If we had to get more oomph into our application, then we could easily deploy our app into a premium plan. The code required for that, I've shown that a bit earlier, if you remember, but it's also going to be shown later on again. Great thing about the use of queues for us was that they are based on Azure Storage and inherit the storage account's durability SLA and other metrics, and properties, which means we're absolutely not at all worried about missing messages that we need to execute, because all of this is again built into the platform. So this was great. Everything's great, everything's awesome, but then this happened. Might be a bit difficult to see at this scale, but look at the memory consumption of our app and really how at this point it's above 1 gigabyte almost constantly. Well, just 2 weeks ago, and we always add more features and we get more people to use the app. We get more customers onboarded, but really, here's where our application steadily outgrew the consumption plan's 1 gigabyte memory limit. And we could have probably refactored the app, and we might do that in the future, deployed functions into, into separate function apps on other plans, spent time and money doing that, or really just deploy the application into a premium plan that has access to more memory at this point. So this really only meant changing 2 lines of code that we already had ready to go, and wait 5 minutes for the pipeline to deploy the infrastructure changes. Really, this was a no-brainer, and we opted to deploy our function app into a premium plan. So for the backend, for the database, we also had to make a decision. We had to make that choice on Azure between SQL Server or Cosmos DB. SQL Server is very well known in the industry. We've all worked with SQL Server, I guess, in one way or another, but it's really not cheap. Even when going with the new serverless tier that Azure SQL offers. Cosmos DB is still cheaper, especially because it also comes with a nice free tier that we could use, we could make use of in our early stage, as long as we wouldn't go and hammer the database too much. So at the moment, we pay around $300 a month for our Cosmos DB, which is probably somewhere half of what we would pay for SQL Server right now. That said, we also feel that our Cosmos DB database is far from optimized. We leave most of pretty much everything to the platform, including scaling. Cosmos DB comes with, however, also compared to SQL Server, some really nice benefits via its NoSQL nature. Has super fast writes and reads, even across regions. And it's really simple to integrate into Azure Functions, or really simple to integrate functions into Cosmos DB. And it also still supports SQL APIs when communicating with it, which means that pretty much our developers at the moment, all they do is they write SQL queries to talk to get data and information out of the database, and they find it super easy to work with Cosmos DB. We also don't have to think about patching any infrastructure or updates. And we get high availability in our region for free by getting 4 replicas of data in this one region that we're in. And you can see in our infra code towards the end, if we wanted to go multi-region with our database, it would be really simple for us to just add a few more lines of code in here, and the platform would replicate across multiple regions. In fact, it would be a 0 downtime deployment. Cosmos DB for us also meant that it would nicely grow or scale with our demand. We really mostly pay for what we use, and when we grow the database, it automatically scales its request units based on our demand and make sure our queries don't slow down. Part of the future optimization that we envision will be to define some scale limits for each container, which we can then define and update via Pulumi, for example. To give you an idea what that might look like, that in the screenshot here, there's a throughput of 800 request units per second on the database. But I do encourage you to read up on the metrics used by Cosmos DB, as this really goes beyond the time that we have available today. To give you an idea of our current scale, for the $300 last month, we executed approximately 7 million requests to our database every 24 hours. Yes, I was honestly quite impressed when I saw those numbers. And we're not storing too much data, as in we don't need too much storage, but we have a lot of requests going into our database. So let's quickly touch on our third-party integrations, the things we decided not to build ourselves and or buy as a service. Starting with Stripe on the left, which offers really easy payment integration to our application. They also have a really nice startup offer, which is amazing, so we don't spend too much on this. Also, Stripe meant that we did not and do not, and I cannot emphasize how badly I don't want to have to worry about that. We do not need to be PCI compliant in order to give our customers the ease of paying via credit card. If anybody's gone through PCI audits before and getting everything PCI ready, you hopefully you can relate. To integrate Stripe, it probably took us a day or two to get that done. For our code repository and CI/CD, we use GitHub Actions, GitHub and GitHub Actions, and we're not paying a single cent to GitHub for pretty much everything they offer to us. We have our backlog on GitHub, our projects, and like I said, our repos and pipelines. We get around 2,000 minutes of actions every month, which is plenty of time for us, because every deployment and build takes somewhere between 5 minutes for the actual app and 10 minutes for the front end. So that's pretty good. I did ask earlier, but I really didn't want to go back to my early days of my career and look after Exchange servers or deal with Outlook APIs to send emails. And I didn't want our developers to do that either. SendGrid really honestly made it so easy for us to send emails, even formatted or templated emails to our customers. Was really a no-brainer to pick SendGrid for our email transport. On top of that, Azure Functions also support SendGrid as an output binding, which means that in order to send an email via SendGrid, we only had to add 3 lines of code to our Azure function, and that was it. 3 lines of code, and our application knew how to send emails. That was pretty cool. Auth0 is what I, as a user, always want every other product to offer. We don't ask our customers, our users to create logins and passwords. We don't store their credentials. We really don't care or even want to know their passwords. All of this is single sign-on to our application thanks to Auth0. They allowed us to integrate their service into our website in, I think I need to check again, but it's around 15 lines of JavaScript. And with that, we had full single sign-on in our app. 15 lines of code. We support Azure AD, Google ID, many others in really just a few hours of work. And on top of that, they also have a really nice startup offer, which makes it free for the first 12 months for us. So we picked those third parties very carefully. Again, security is our top focus. We researched these offers, but we believe that they can deliver the thing we need much better than we could ever build. It's not our business to to offer password resets or to offer credit card payments. Our core business is something else. We want to focus on that. We didn't even try building our email capability. We integrated into our app, which meant we could focus on being great at what we wanted to be great at. Well, this brings me to my conclusion or takeaways after around 8 months or so of building the startup on Microsoft Azure. Focusing on the application and only the core functionality meant that we didn't need to worry about all those accessory services. Focusing on the application and only on the core functionality meant that we didn't need to worry about all those accessory services like email, payment, identity, or well, the others. But we were able to quickly build and iterate on our own offering. Scaling is built into the infrastructure. In the beginning, there was almost no load on our infrastructure, but we knew that was going to change, but we didn't know by how much. We had our plans and hopes, but it's always a question, right? Well, by relying on auto-scaling or being able to make simple changes to our infrastructure code and receive more power pretty much on demand from the infrastructure when we needed it, we got to the point where we really aren't worried about getting more customers. I don't ever want to show my customers these dreaded HTTP errors, error pages that pretty much mean I, as the product vendor, don't know how to scale my infrastructure. The screenshot here from Application Insights shows that over the last 30 days, our application itself executed around 11 million times, which is pretty cool. But on the flip side, our decisions also meant that we were locked into Azure. And we can probably have a full session on if that's a good or a bad thing. But in this case, we were locked into Azure. I mentioned that this is good, but it's also not great. It's good because we can leverage all the cloud native capabilities. But if we run out of money for even a time and another cloud provider comes and offers us some nice credits, what are we going to do then? Being a user of some of the more modern cloud services does mean that people tend to be very eager to join the team. And using a language that is super common made it even simpler. One thing we did learn very quickly was that Application Insights, as great as it is and as super helpful as it is, was going to be the most expensive part of our application. And it's still a concern to us because, for example, our application is very busy, 11 million executions a month, 7 million database requests. per day, it creates a lot of logs. And logging is expensive. And we actually had 1 month where it changed to the application insights config, made it into production. We didn't fully understand that change, and it actually ended up costing more in that month for logging than what we paid for the whole app itself, or the core application itself. So that was a very interesting lesson. But overall, with the numbers I mentioned, at the moment, our application costs us around $600 Australian dollars a month. Because we are now on the premium plan, the Azure Functions premium plan, we expect this to go up by another 200, maybe 300 in the next month. That's still an estimate. But still, I would say for the number of executions, for the scale that we're at, for the pace of development that it gives us, for building a startup, these are excellent numbers. So I trust you enjoyed looking behind the curtain on how we build our startup on Azure and what drove our decision making. So thank you very much for spending your time with me. And also remember, this session is recorded and will be available on YouTube and on Channel 9 apparently in the next 2 weeks. Thanks again. I hope you learned a lot, and see you next time.